Dave Thiessen with PrairieLand Partners Product Support, and today we'd like to talk about optimizing your machine in small grains. As you can see in the machine, we have a new set of concaves set up, and for visual and easier explanation, we'll talk about it here on this display. In the past, we've recommended small wire concaves in this front position, and John Deere and Condex, an allied partner, have come together and created a new concave that we have been replacing the small wire concave with on the front position for a few years now. And what we have found is we gain an optimizer machine with threshing efficiency and quality of thresh right up front here, being more aggressive. And so let's just visit about that a little bit. These helical bars that you see cut at this angle really do help that crop as it comes in and starts to thresh aggressively, be more aggressive. We're finding that with this Condex Concave Max Thresh setup, we can run the concaves just a little bit more open. As material comes in and threshes against these helical bars, it really interrupts the crop flow, so the material on material threshing starts to happen. And then we have these oval holes that help hold that crop material up in there, but yet release some grain through that's been threshed, giving us more horsepower to apply to the machine in other areas to be more efficient. And then behind that, depending on what crops we're in, we'll run small wire concaves in the small grains. But as we go into fall harvest, we've been leaving this concave exact setup in here. And we find that when we're harvesting corn, we peel the husks off the grain, the corn ears, and get it ready to thresh on the round bars behind it. And in soybeans, we're more aggressive. And then also in milo, it's been a very good choice. So we've found that we can leave it in for all year. But let's talk about small grains. So when we bring in that crop in small grains and we're doing material on material threshing like a rotor is designed for, and we open up a little bit more, we allow that machine that more efficiency of fuel economy and throughput, but also it allows that material on material to be more aggressive threshing. And we have this second concave that's a small wire and the third concave small wire. Well, if I was in a class 8 or 9 machine, this is my setup in its efficiency for holding the crop up in there and doing a good job of threshing with this Condex Max Thresh. And in my class 5 and 6 machines, we still have our tailings elevator that returns into the center section of the second concave. And we're going to still encourage you to put in cover band in that position so that when we put that in underneath this concave, we're holding that material up in and doing a good job of threshing. Now let's talk about the third concave. The third concave, we have a couple choices there that we do. If we have a struggle with white caps in that conditions of maybe there's some moisture still in the crop and things are just not wanting to thresh out and separate correctly, or the variety of crop you're in is hard threshing, I'm going to have you leave in every wire in the small wire concave. And that would be especially in our class 5, 6, and 7 machines to help remove those white caps and clean up that sample a little bit better. But if I'm going to a class 8 and 9 machine and I have maybe more horsepower than I have separation capacity depending on how it's threshing, I would encourage you to pull every other wire out of that rear concave in that third position, or put a large wire concave in that position to allow us more separation room. Keeping in mind that we might increase our white caps or have to run a little higher tailings volume, but if we're looking at optimizing a machine, that's how we'd want to talk about that. Below the concaves, we have these shoe auger bed dividers, and you've maybe seen these underneath your concaves. These shoe auger bed dividers are on the inside of the first auger on the left and the second auger on the right, and what they are there for is to help the material that falls through these concaves get directed to the right place to be put onto the chaffer evenly. With the momentum of that rotor running at the speed it does, and especially in small grains, and the higher the rotor RPMs, the farther up on the slots we need to go. We need to pull those shoe auger bed dividers up so we keep more material in the middle of that chaffer, not putting it to the outside edges. And these are right underneath the concaves, right in here below the concaves.